Hey, what's up everybody? My name is Moss, and in this video, I'm going to introduce you to OpenTelemetry's Declarative Configuration, which is a new method for configuring the OpenTelemetry SDK in your applications. First, I want to give you a brief introduction to the Declarative Configuration feature and why you would want to use it. And then I'll demonstrate this feature using a simple application written in Go. We'll use Splunk Observability Cloud as the backend for our telemetry data. Declarative configuration means configuring OpenTelemetry by defining the desired end state using a YAML file instead of writing lots of detailed programmatic code. Instead of specifying exactly how to achieve observability, you just specify what configuration you want. Now, why would you want to configure OpenTelemetry using this method? Let's start by looking at some limitations of traditional methods like environment variables. With environment variables, you can set things like exporter endpoints, sampling rates, or service names. But environment variables are limited in their expressiveness and they're difficult to maintain. They aren't designed to handle complex data structures needed for configuring things like specific trace processors or detailed metric views. And each programming language has its own idiomatic implementation for OpenTelemetry. The specific classes, methods, and patterns you use to instrument a Python application are different from those you'd use in Java, Go, or PHP. And this means developers or platform teams need to learn and maintain OpenTelemetry configuration code specific to each language used in their stack, increasing the effort required to achieve consistent observability. Declarative configuration reduces the cognitive load on your development teams. For instance, if you're an AI engineer, your primary focus should be on creating new AI features, not writing custom observability code. Similarly, as part of an observability or platform team, you shouldn't have to spend your time manually instrumenting dozens of applications. With declarative configuration, you can define your observability setup once in a single YAML file, and then apply the exact same configuration logic across applications written in different languages. The result of this is that declarative configuration significantly simplifies and reduces the amount of instrumentation code developers have to write. It provides development teams an easy on-ramp to integrate their organization's observability solution into their applications without writing extensive boilerplate code. Now that we've done a brief introduction, let's see declarative configuration in action. Let's take a look at the code of my simple Go application and the declarative configuration config file. This Go application is a very simple web service with a single endpoint. If I scroll down, you can see the definition of the handler function for our single endpoint, and it's simply returning this string to the client, and then it's logging an arbitrary message. We'll review the metric counter in a little bit as well. That handler function is wrapped with OTel HTTP so that we can retrieve telemetry data from requests. And then we register our single endpoint, which we're calling the health endpoint, and passing in the wrapped health handler to the handle function. Now, if I scroll up, you can see that we're creating a new logger using OTel. And then in the main function, we're creating an empty context, passing that context to this setup OTel function, which is returning the OTel shutdown function. And when the program ends, the OTel shutdown function will be called to perform a cleanup of the OTel SDK. Let's take a look at this setup OTel function because this is where we would be configuring the OTel SDK. In the first section of the setup OTel function, we are reading in the config.yaml file, which is specifying the configuration for the OTel SDK, and we'll take a look at that in a minute. Once the file has been read in, we then call the parse YAML function from the OTel configuration package, and this will return a structured in-memory model of our YAML configuration. Once we have the configuration file in memory, we're then initializing the SDK and passing in that configuration file. With the SDK initialized, we can then set the tracer provider, the meter provider, and the logger provider. This is all of the code that we need in order to configure the OTel SDK when we're using declarative configuration. Notice that in this code, we're not specifying endpoints for telemetry data to be sent to. We're not specifying processors and exporters or any parameters for processors or exporters. All of that configuration is happening in the config.yaml file. The last thing that I'll show before we move to the config.yaml file is the definition of this custom metric, which you'll be able to see in Splunk Observability Cloud. Here we're defining a meter called health metrics, and then for that meter we're specifying a single metric called health check passed, and it's just the number of health checks that have passed. Essentially, this is the same thing as request count, but just to demonstrate how you can create custom metrics and view them in Splunk Observability Cloud, I wanted to create this custom metric here. So anytime the health handler is called, this health check passed metric is incremented by 1. Okay, so now let's take a look at the config.yaml file. At the top of the config.yaml, you'll notice that we're specifying resource attributes that are appended to the telemetry data that we're sending to the backend. So we don't have to specify resource attributes in our code. We can specify them here in the YAML file, and they will be appended. And then below those resource attribute definitions, we're then configuring the tracer provider, the metric provider, and the logging provider. For our tracer provider, we're exporting traces to the console, but we're also sending traces to Splunk Observability Cloud. An important thing to note is that you can define multiple batch exporters with multiple endpoints to send trace data to. So in this case, if I wanted to send trace data to a local OpenTelemetry collector, I could just uncomment this out, and we will have trace data being sent not only to this endpoint, but also to the Splunk Observability Cloud endpoint. And again, for the meter provider, you can see here that we're exporting to the console, but we're also exporting to Splunk Observability Cloud. And if I wanted to, I can export metric data to a local OpenTelemetry collector if I wanted to. And all of the parameters that I would have to programmatically specify in my Go code, I can instead specify those parameters here in the YAML file. And then finally, we're defining the configuration of the logger provider, and it's exporting logs to the console. It's exporting logs to a locally running Splunk OpenTelemetry collector, and it's also exporting logs to a Splunk HEC endpoint. One thing to note is that the Splunk HEC endpoint cannot process protobuf data. And as far as I can tell, HTTP over JSON is not yet supported for logging exporters. And so I'm sending this data, but to the raw HEC endpoint. Although it is successfully sending data to the endpoint, the protobuf data is incomprehensible once it's in Splunk Observability Cloud. I just wanted to show this as an example of how you would potentially configure Splunk HEC endpoints in the declarative config file if the HTTP over JSON configuration was available. And since this logging exporter doesn't quite work with the Splunk HEC endpoint, I'm forwarding logs to a locally running Splunk OTel collector, and then that Splunk OTel collector is sending logs to the Splunk HEC endpoint using an HEC exporter. And I'll quickly show the Splunk OTel collector's configuration. So under exporters, we've defined the Splunk HEC exporter, and we're passing in the token and the event to send HTTP events. And then we're adding that exporter to our logs pipeline. And so for my particular scenario, since I want to integrate logs, metrics, and traces in Splunk Observability Cloud, I do need to have this separate Splunk OTel collector processing log data and sending it to the Splunk HEC endpoint. So now that we've walked through the code and the configuration files, the first thing that I'm going to do is run the Splunk OTel collector, and I'm running it inside of a Docker container on my machine. So I'm using the Splunk OTel collector image, and I'm passing in some environment variables. I'm mapping ports 4317 and 4318 to the host ports, and then we're also passing in the OTel collector configuration file. And remember that this Splunk OTel collector instance is not sending trace or metric data to Splunk Observability Cloud. It's only forwarding logs to the Splunk HEC endpoint. The next thing that I'll do is run my Go program. And it looks like my Go service is running, so I'm going to simulate some client requests hitting that health endpoint. So I'll curl that health endpoint. And we should see some output from the OTel collector confirming that it received metrics, traces, and logs. And it does look like it's receiving metrics. And if I scroll up, we should be able to see traces as well, and possibly a log line that was processed. So it looks like there were some logs that were processed as well as traces. And if we take a look at the debug console of my Go program, we can also see the output of the metrics, traces, and logs. So now that the program is running, we've created some requests. We should be able to see this data in Splunk Observability Cloud. So I'm going to navigate to Splunk Observability Cloud. So from the home page in Splunk Observability Cloud, I should be able to see my service in APM. From the APM homepage, I'm going to scroll down and I'll select my service. And from here, I can see those requests coming in under the success rate SLI chart. And if I scroll down further, I should be able to see other metrics related to my service, like the number of requests, as well as service latency and service errors. And I think it's important to point out that these are metrics and charts that you're getting out of the box. I didn't have to configure this dashboard at all. These charts are available as soon as I start sending data to Splunk Observability Cloud. I can also look at error breakdowns, runtime metrics, and infrastructure metrics if those are available. And in the top right, you can see the service map, which is obviously very simple. Now, it's great that we're getting high-level metrics, but where are the traces? If I scroll back down to the service request chart, I can click on a data point in the chart. And it will render an in-context window showing me related traces to those data points that I see in the chart. And you can see here, I can go directly to the traces that were processed. Clicking on that trace takes me to the trace waterfall where I can analyze specific spans, and then in those span details, I can get a lot of additional information under the tags that are associated with that span. And something that's very important to note is that if you look at the bottom here where it says infrastructure and logs, this is called related content. And if there's correlations between traces and infrastructure or traces and logs, you will be able to see those logs from this window. So if I select logs, you'll notice it says that there's one log here. And so for this particular trace, I can navigate directly to the log lines or the log entries that are associated with this trace. And so this takes me to Log Observer, and it's already filtered using the trace ID that I was previously at. And so I can just select the log entry and review the log entry message and other data. So using that config.yaml file, we're receiving metrics and traces, and logs are, of course, forwarded using this kind of proxy Splunk OTel collector. And we're getting a correlation between the logs, metrics, and traces as well. And one thing that I defined in the code was a custom metric that I wanted to quickly review inside of Splunk Observability Cloud. So that custom metric you didn't see in the dashboard for our service, but if we wanted to, we could create a new dashboard with a chart using that metric. So if I wanted to find that metric, I would navigate to Metric Finder, and then I can search for metrics based off of various attributes of my service. I'm going to use the service name. and then I'll select my service. And now I can see all of the metrics that are associated with that service name. And let's find that health check passed metric. Okay, so there's my health checks passed metric, and I can select it. And it brings up a chart where we can see the value of that metric over time. And if we wanted to, we could add this chart to a custom dashboard and also add a detector based off of the values of this metric. So we could configure a detector to send an alert anytime this metric meets a certain threshold. I'm going to navigate back to the service view in APM. To summarize, declarative configuration offers a powerful way to manage your observability configuration. Instead of adding configuration programmatically within each application, you define the desired state and specify where you want to send your telemetry data to in a central YAML file, freeing up your developers to work on core application logic. It gives you the flexibility to change your observability configuration without having to make changes to your application's code. And although I had a collector running in my example, you don't necessarily need to run collectors on every machine. The last thing that I'll mention is that declarative configuration is still in development. I will link to in the video description the OpenTelemetry declarative configuration specification. In that GitHub repository, there is also an open issue that outlines what languages currently support declarative configuration, and I will link directly to that issue as well. I'll also link a presentation delivered by the maintainers of this declarative configuration feature and a demo repository that they created, which heavily inspired the samples that you saw in this video. I hope you enjoyed this video, and if you did, we'd love to hear your feedback. And if you're interested in trying Splunk Observability Cloud yourself, you can navigate to this link to claim your free 14-day trial. Thanks for watching.